So you can compute it, but you can approximate it. And the way you approximate it is by computing a testing error. So the way you do it is you have your training data. That's the data that you have today. You take this data, you split off a certain part of it and call it a testing set. So that's the data that you will pretend you don't see. That's the data that you will pretend will come tomorrow. Okay? And then you can compute the error just on that testing set. So same equation as for the training error, only now you're computing it over this held out testing set. And the critical thing, in order to do it, honestly, when you're building your classifier cannot ever look at any part of this testing set. If it does, it will be overfitting to it. So you train it on the training portion, and then you compute the error based on the testing set. And that will give you an estimate for the future error if the testing set that you have sampled is representative of the data that comes tomorrow. And that, of course, is a big if. But you don't know what data is going to come tomorrow, so usually the assumption is made that you do the sampling in the way that will best approximate what happens tomorrow or a month from today. And if you do it that way, if you can assume that your testing set is unbiased, then by the law of large numbers, you know that your testing error will actually converge to the true generalization error if you take a very, very large testing set. So what you know is in the limit, the testing error will be the same as the generalization error. So it'll be close. But the interesting question is, how close is it going to be? And the answer is, it turns out it depends on n. It depends on how many entries you put into the testing set. So the more entries you have in the testing set, the closer your testing error is going to be to the generalization, to the true future error. And we'll go through a derivation that sort of shows the relationship. So let's say we have an example. We have 100 instances. We're doing binary classification. And let's say we classified 75% of them correctly and 25% incorrectly. So your testing error is 25%. What this means is that the generalization error will also be somewhere around 25%. But how close is it going to be to the 25? Can we get a sense of, is it 25 plus or minus 0.5 or 0.05, or is it 25 plus or minus 10?